Sorry, it was disconnected. So VBF protection is one of the reason for that, and also the VBF is nothing but when the voltage, you know that the flux, which is nothing but the flux. When the flux is high, obviously it will it will overheat your transformer windings and the core. So which because of the flux overflux that can be controlled. The flux protection, so nothing but a overflux protection. This overflux protection can be detected by the flux cannot be detected in the transformer, so it can be detected by the factor of V by F. So the V by F protection is also required for the transformer. So it's maybe due to the high voltages or maybe the low frequency in our gate, it may affect on your transformer. So the flux will be rises up. If the flux is going beyond, though, it will again damage your core. So to avoid that, we are doing this. So because of instability in the grid. So these are the general ways, ways of protection for the transformer team. So again, I will show you this differential protection, low impedance, high impedance settings, and restricted earth fault settings in our next classes. So let's come to the very important protection, which is the distance protection and the line protection. So what is the protections generally will be there in the line? So we are having a distance protection, a carrier send, which is 85, 68 power swing, 79, 67 or 67N, 51N, and disturbance recorders and over voltage, under voltage, and load encroachment conditions we have to consider, out of step. So other things, all protections will be, so many protections will be there in the differential protection thing. Pilot wire, actually till now we had done with the normal distance protection. I have not came across with the pilot wire till now. I have not used it for any my projects. Sorry. Let's discuss all. If you feel any doubts, we will discuss about it. So come to the line team. We are having so many protections. So in this, the main protection is the distance protection. What is the distance protection? Why require this distance protection? So the main important protection is the distance protection, which is working with the principle of impedance of the line. So if the calculated impedance and if the apparent impedance or applied impedance means applied impedance like voltage with respect to the current, if the both are same, then your protection will not be operated. If it is more or less, then your differential protection will be operated. If you place this condition can be attained only for single line. But again, what is the case? Suppose I am having a relay here. I am having a feeder, a line here, and this is also one more line, and this is also one more line, and this is the breaker line. Suppose if a fault occurred here, take F1. This is the fault occurred. If a fault occurred here, then suppose let's assume this is a 400 kV system. 400 kV system. Let's assume the impedance of this line is 10 ohms, and this is 10 ohms, and the impedance of line is 4 ohms. Now, when you are implementing the distance protection, you have to protect this is the A substation and this is the B substation. These are the two lines going out. These are the two lines going out, and from B, one more lining going out. So all this to be coordinated. First case, if I am using the overcurrent protection here, then let's see, if a fault is coming in this direction, then For this, if I am implementing, if a fault occurred here, it should be operated in 200 milliseconds. Then this should be operated in 400, 600. So what is the source? In India, the entire grid is very meshed network. So we cannot detect this, we cannot grade this based on this, based on normal overcurrent protection. This is the way our general overcurrent protection works. And again, suppose a fault occurred here, then what is the fault value here? In a simple calculation, 400 by root 3, which I am calculating the current, and I also am dividing with the per unit impedance. These are in parallel, so 5 for 10 plus 10 by 10 by 2 plus 25 plus 4, 9, right? So what is the answer for this stream? Let's see. Yes, it's coming to nearly 25,600 amps. This is the current. I'm saying that if the current is this, then you have to follow, you have to operate this breaker. In the same case, if a fault occurred here and one of the line is failed in that condition, then what is the current? 400 bar root 3 into 10, right? Suppose this is a fault, 10. 40 by root 3. 40 by root 3. Yes. Then the fault current in this case would be 23,000. So what I am saying to this breaker, to the line when I am grading, if the fault lies between this period, then it has to be operated. But will you confirm whether the fault will be in this range? It's practically impossible to this. So that is also one more disadvantage for using this overcurrent relay. So to avoid this, to avoid all these scenarios, we will implement the distance protection. We will talking about the distance protection. So before entering into this, what are the different types of faults occur in the line? We are having two faults. One is a transient faults. We will talk. Otherwise, are persistent faults. Persistent faults are broken conductor, bird falling, bird sitting in that, or tree fall. These things. So not bird sitting, broken conductor, or tree falling on this, or insulator damage. These things. Coming to the transient, all the transmission line faults, lightings, or birds sitting on this. This means touching two phases. So these will relate to transient faults. So when you are selecting the relay, we already talked about this. The relay should be speed, should be sensitivity, should have selectivity, should have security, and should be reliable. So in the differential protection, in the distance protection, by considering all these things, selectivity, sensitivity, speed of operation, security, reliability, all this, the directional protection is the best way of doing for the transmission lines. Sorry, distance protection. And it was also this before, we can protect to this different distance protection using the differential protections also. In a practice in India, generally, if the line lengths are more than 10 kilometers, it is recommended to go for distance protection. If line lengths are less than 10 kilometers, differential protection is a fine, good way to do that. So in the differential protection, you can see the pilot wire protection. That is a differential protection, generally how it works. But I have not done for any project. Mostly we use it as the distance protection because all the line lengths are more than 20, 30 or 40 kilometers. So come to this line. In the distance protection, we have to talk about the zones of protection. Zone 1, Zone 2, Zone 3, main. Zone 4 is a reverse chain. Fine. Zone 1, Zone 2, Zone 3. So what is this? So let's assume this is my A substation, this is my B substation, this is the C substation, and this is the one more substation. This is the A, this is the B, this is the C. So we are having the breakers, breaker. This is the D substation. This is the breaker. This is the breaker. So I want to protect this I am protecting this. So how I will do is I will consider 80% of the line under the zone 1. 80% of the line should be covered on the zone 1, and 120% of the line, the next line, the longest line is under the zone 2, and 180% of the line is falls under the zone 3 for this relay, because it has to protect this way. It has to protect in this direction. So to protect in this direction, the CT connection should be at the towards this protected object. So Z3, this is the zone protection, which is a 180% of the line. 180% of the line. Zone 1, zone 2, zone 3. And the similar case, this is the my line I am protecting. Similarly, for the B, there is a breaker, there is a relay. For this is the zone 1 protection, 80%. One 120% of the line, it comes under the zone 2. Zone 3. Seems if lines are there, suppose zone 3, 180%. So in general, the zone 1 for this breaker, if a fault occurred in this condition, then it is a zone 1 for this A breaker. So if a fault occurred in the zone 1, the breaker will trip instantaneously. The breaker will trip instantaneously. For zone 1, the breaker will trip instantaneously. If a fault occurred in this case, I am talking about for this. So it is not in the zone 1. It is in the zone 2 for this. It is coming under the zone 2. So for this breaker, for the A breaker, that is the zone 2. For the B breaker, it is a zone 1. For B breaker, it is a zone 1. So then this breaker has to wait not with respect to the buses. Zones will be done with respect to the line lengths. So this is the general I represent as a bus. These are the lines. With respect to the line lengths, we are considering. A breaker, for it is a zone 2. Zone 2. So we have to provide some grading between the zone 1 and zone 2. So zone 1, I said instantaneous. Zone 2 is 350 milliseconds. This is the setting for zone 2. And zone 3 is 800 milliseconds. This is a setting for the zone 3. 300 and 800. Means if for the A breaker, zone 2, the relay will be operated after 350 milliseconds. But in this breaker will be operated instantaneously. So it's already confirmed that there is a fault in that breaker, in that side, but I have to wait up to that. So I don't want to wait. I know there is a fault. I want to trip immediately. So in the same case, if it is a zone 1 here, zone 2 here, so I have to trip all these breakers. If this breaker is tripped, this breaker to be tripped. So to trip this inter-tripping of the breakers, if one breaker tripped, other breaker to tripped, there are different types of schemes are there that we will call as a permissive inter-trip schemes. One is one is the dot put pot. These are the some inter-trip schemes, put pot, dot, these things. Dot and dot we are not using now because these are direct trippings, like U is underreach, O is overreach thing. What is underreach or overreach? I will explain. Dot is dot and dots are direct trip. Means if this breaker is tripped, this breaker will trip. That's it. No condition, nothing is there. These are relating to the mal operation of the relays, because this relay mal operated and it again doing this. But to get the confirmation and to make it a very close operation, means very reliable operation of the relay, these schemes generally we are implementing in our projects. One is the put operation, other one is the pot operation. What is the put? What is the pot? Put is permissive underreach transfer trip scheme. It seems that if if the fault is the zone 1 fault and I am sending a carrier to this, so the carrier which is sending this one with the 85, which is 85 is the carrier send MC code. The carrier send plus zone 1 is the trip for this. Suppose if a fault occurred here, then for it is a zone 2. So B1 give the carrier send and plus zone 1 for this. It is sending a carrier. Then I have to receive the carrier from this. That's carrier receive plus, and I have to find my relay should be pick up at zone 2. Should be pick up at zone 2. So the relay which is sending by the B is the carrier send plus, it is sending some carrier and the zone 1 should be pick up in that relay. And when I am receiving the carrier in this relay, carrier receive, the carrier should be received, and other condition, this relay should be pick up at zone 2. So this carrier and the carrier receives will be communicated with some platform, that is a jet communication, jetcom. So jetcom, using the jetcom, this process will be gone. So when it carrier send and zone 1, when it carriers is zone 2, so if this condition is arrived, both the breakers will trip instantaneously. Means it is already tripped instantaneously. It is sending that, so it will also trip instantaneously unless until waiting up to 350 milliseconds. It seems. So this is the put scheme, permissive underreach transfer scheme. And other scheme is pot scheme, which is permissive overreach transfer scheme. These schemes generally rarely occur. This scheme is maybe due to the short lengths, 3 kilo, like 10 kilometers or less. Maybe due to the ground arc fault resistance, the both relays are showing a zone 2 only. Zone 2, zone 2. So if the both relays are zone 2, so carrier send, carrier receive, so it resembles to the pot scheme, permissive overreach transfer scheme. Because why it is falling at zone 2 on both? Because of the arc fault resistance, which is creating an impact on this, impact on the impedances. So this is the zone 2. So always zone 1, zone 2, zone 3. So again, the zone 4 is the reverse direction. Zone 1, if the zone 1 is pick up, and we are sending a signal to the other end of the breaker with some jet communication that I am seeing a fault at zone 1. So what is your case? If it's seeing a fault at zone 2, and if it receives the carrier, it will also trip. So this is the main scheme. Generally, we will see. And come to the pot scheme. Someone asking to repeat pot scheme. So I am having a small line. I said this is the zone 1 for this, and this is the zone 1 for this. So what is this is the case for zone 1. So maybe due to the arc fault resistance, this is overlapped. So it seems that it is appearing like this. So this is left and left for the zone 1. Because of the ground fault, arc resistance depends upon the type of fault. So for this, it is a zone 2. For this also, it is a zone 2. So zone 2 plus carrier receive, zone 2 plus carrier send will trip under this condition of pot scheme. This may happen. So again, to avoid this time delay, to make it more time, that is a pot scheme. These are the different types of schemes. And one more scheme is POTT, permissive overreach transfer trip. Mic is already given, right?
You told me that actually, see, when this more than the 80% of the fault, actually, there is a fault in the zone 2, actually. If it is zone 2, there is a fault. The breaker A, it will send the carrier to the breaker B, right? Once the breaker B, it is receive the carrier, automatically what it will happen for the B, it will be the B, it will be the zone 1 fault. That means it will trip already, it will send the carrier to the zone 1A, right? So once
That is
the carrier in the A breaker,
that is fine for the put scheme, POTT.
correct.
That is for PUT.
Correct. That is for PUT. When that carrier is received to the A breaker with the zone to pick up, so automatically it will go for the PUTT. That is correct. Now you are trying to say something, this overlapping, because still I could not able to understand actually this is which type of fault.
See, this is the zone 1 for this relay.
Okay.
And this is the zone 1 for this relay, right?
Correct. Okay.
So this is the overlapping. Fine. Means now maybe due to the arc fault resistance, means the fault occurred, severe fault occurred. Due to this, this is ground fault, right? Maybe the arc formation of this fault, severe fault or ground resistance. So this impedance is getting showing effect on this. So some cases, what will happen is, so actually this is like this, but due to this, the relays of seeing the fault, this relay is seeing the fault in zone 2. This relay is also seeing the fault in the zone 2 only. Means it is appearing in middle. It may be, I'm just making this imaginary. So in this cases.
No, 1 minute. Suppose you are saying that fault, it is in, see, the below the 80%, it is a zone 1 fault, correct?
Okay.
Now you are just putting for the breaker A, some of the portion, maybe the 50 to 60%. Okay. Okay. You are considering
this is a fixed one. But now I am calculating the impedance. So this impedance, if I say suppose Z1 is the impedance of this line is 80 ohms, is 80 ohms, then it is a zone 1. Okay.
Correct. Okay.
And if for this zone 1 also, suppose 80 ohms. Suppose. Okay. This is the case.
80%.
80%. Suppose let's
maybe
assume
below the 10 to 15 ohms only total line length actually.
Okay. Now the fault occurred, severe fault occurred. Maybe due to the severe fault, now the calculated impedances is equal to which is very high, not 80% in this case. So it is leading to the zone 2. But actually the fault occurred here only. But due to the arc fault resistance, that zone, it is not showing in the zone 2, it is showing in the zone 2 for this. Similarly, for this is also it will happen. Both the cases, both one seeing the fault in the zone 2. Due to the arc of ground fault resistance, there is a very high resistance.
That is, you are saying that high resistivity fault?
Yes. Very, very rare case.
Now, the high resistivity fault, when it is come under the below the fault
broken conductor,
away from the fault impedance.
Broken conductor.
See when you are that will be when it will not come under the below impedance level, it will go behind the impedance level.
Yes.
That means automatically it will not come in the picture. The distance it will not operate in this case actually. Distance it will not operate. It will go for the directional actually. The directional it will take care automatically. Now this condition, that means you are saying that there is a fault in the 80% for the A breaker. So another B breaker also, B breaker maybe, see, A breaker maybe 40% of the fault, B breaker is 80% of the fault. Now that means both the breaker, it got confused. That means this A breaker is zone 2 fault, B breaker is zone 1 fault. But it is confused the relay, it is taking a zone 1 fault. Both it is a zone 1 or zone 2 fault, right?
Zone 2 only. Zone 1 obviously it
Zone
will
2
be there. In
that
normal
means
case
this is called as
also, if a fault occurred, it would be zone 1, it will show. But it is very rare if it is not possible to show zone 2 for both. It is not possible.
correct. Yes.
Yes,
Correct.
but due to this, some instances of high arc resistance, fault arc resistance, it is showing a zone 2 for both.
But that means what is the real condition of fault? You are saying that you put some line. What is the for the A breaker? What is the percentage of the fault? What is the B percentage? What is the percentage of
Maybe
real fault? You can see.
maybe due to the insulator damage
Okay.
with a high
That means
arc.
the real that means the real fault will be the zone 1 maybe more than the 80%. For the B breaker maybe less than maybe 40 to 60%. This is the real fault condition you are saying. But due to this arc resistance, it is taking as a it is got confused with the B relay. It will take as a zone 2 fault. That means
Yeah.
P also it is taking as a zone 2. But
Yes.
A is normally A fault is normally zone 2. The P fault is normally zone 1. But B relay it is got confused, but it is took as a zone 2 fault. Okay,
Well said.
that's what you were saying, correct?
Yes, yes, yes.
That means it is called as underreach or overreach, right?
Overreach.
Overreach.
Yes.
Overreach, right?
Yes.
But same thing, underreach also. I need this explanation with drawing actually.
Underreach. Now I said right. Underreach in the underreach put scheme. What is happening?
This is overreach, right?
Is underreach. PU under.
Correct. Okay.
Now in this case, this is the zone 1. This is the zone 1. Suppose a fault occurred here. For it is a zone 2. For it is a zone 1. So it will it is detecting a zone 1 and it will send the carrier to this. So for this it is already pick up at zone 2 and it is receiving the carrier. So it will also operate. This is a put scheme. Okay. Now overreach.
Okay.
Zone 1. Zone 1. Okay. Now fault occurred here. Zone 2. Maybe due to the fault arc resistance, this is also showing as a zone 2. Got my point? Okay. So zone 2, overreach. Put scheme. Pot scheme.
No, actually, now which is you are saying the first one, that is the overreach actually. That is the underreach is the when this below the 80% of the fault, that is underreach actually. That means the fault is there. See, the breaker A is there, breaker B is there. There is a fault in maybe below the 80% of fault.
No, we have to see. Let's see. We have to check it the both ends. So for if you see in this direction, but it is also underreach only, right? Then. So it seems to be.
Just see now we will just think about the PUTT. There is a fault in which maybe 40% or we can just say that or 50% of the line there is a fault. Now the A breaker it will consider as a fault is in the zone 1 and B also it will consider as a zone 1, correct? If it's in the 50% of the fault. If it is more than 80% of the fault, until the 80%, that A relay will take as a zone 1 fault. B until 80%, A relay also it will take as a zone 1 fault. B also it will take as a zone fault. If it is more than the 80% of the fault, it will take as a zone 2 fault. B it will take as a zone 1 fault. More than 80%.
Okay.
More than 80% of the fault, A it will consider as a zone 2 fault. B it will consider as a zone 1 fault. In this case, first the B breaker it will trip this one, and when it is zone 2 is detected, this it will send the carrier to the B breaker. Okay. Once carrier receiving the B, what it will do automatically that A wants to trip to the B wants to trip to the breaker, it will send the carrier to the A, almost already sent the carriers. Now this case, carrier receive with zone to pick up already is there, so automatically it will go to the PUTT. Sorry, POTT. It's a overreach. POTT, that is POTT. With carrier receive, with zone to fault is there, it is a zone. It's a POTT. POTT.
Okay.
Suppose, okay, that is now that POTT is finished. Now we will come to the PUTT. There is a fault in below the is 80% of the fault. Now the A, it will send the carrier to the B. B also it will send the carrier to A. But the carrier, there is no meaning actually in this carrier, because both breaker it is in the zone 1 fault. So automatically A also it will trip and B also it will trip, correct?
Yes.
That is the PUTT. The POTT only carrier receive with zone to pick up, it will trip in the POTT. Correct, na?
Yeah, okay. This is all this. Fine.
Hello?
Fault occur here. I'm checking. Suppose if a fault occur here. This is the case. Suppose I'm having A here, and B here. So the fault occur here. Then it could be so for this is I will check and confirm you this. Once again, we will see this.
Because this is what my confirmation is. The POTT is with carrier receive with zone to pick up is that is the POTT. The PUTT is less than 80% of the fault. That means the carrier, if you are sending also, there is no meaning at all carrier. Just to receive the carrier only, but it will not work. It will not trip with the carrier. So automatically it will trip within the zone on fault itself. The PUTT, no need for we are sending the carrier also, there is no meaning of the carrier actually. But more than the 80% only, that carrier it will work actually.
Yeah.
But your case, you told that overlapping. This it will maybe that 80% of the fault is zone 1 fault. The relay, instead of the 80% of the fault, relay may detect as a 90% of the fault. Instead of the zone 1 fault, the relay detects as zone 2 fault. By mistakenly, it is overreached. Because of that zone 1 fault, it is overreached. Then it is detected. It's supposed to detect as a zone 1 fault. By mistake, the relay it was detected as a zone 2. So it is giving the mall operation. It's going for the what is called the overreach. Suppose
Yes,
there is a fault in the suppose there is a fault in the zone 2 more than the 80%. The relay, instead of the 90% of the fault, relay detector is 70% fault. That relay is underreached, so it is going for the underreach. That is only explanation, discrimination only. But the concept of POTT is what is you told that carrier receive with zone to pick up, it is POTT. The PUTT is that sending the carrier, but there is no meaning at all for the carrier, because both it is a zone 1 fault, it is both it is stripping without carrier itself. But the carrier receiving also there is.
Hello.
Yeah.
Yes. As per the name you said is a little bit confusing. Zone 2 plus let me confirm you this.
Okay. The PUTT is zone 2 plus carrier receive is PUTT.
PUTT.
Sorry, POTT.
Yeah, sorry, POTT.
Correct. Yes. PUTT.
Is zone 1 and zone 2?
Carrier.
Yeah, carrier.
Carrier receive with zone to pick up is there, that is POTT. But
yes.
The PUTT, it will send the carrier, but there is no meaning at all in the carrier. Without carrier also, the relay it will detect in the zone 1 itself, it will trip. 80% of the fault, it is zone 1, it will trip it automatically. We are sending the carrier also, there is no meaning in this carrier actually. But automatically it will send whatever it is, because 80% of the below 80% zone 1 it will send the carrier. So more than the 80% zone 2 it will send the carriers.
Okay.
Okay, just maybe you also just check, because I also have clarity when you are coming with a solution maybe tomorrow or something. Okay.
Fine.
Yeah. Okay. Thank you.
Yeah. So, and apart from this stream, and we have to also talk about some more protection here. One is the end fault protection. End fault protection we will enable here. That is, suppose if the breaker is here, if the this is the incoming breaker of this, and this is the CT, and this is the CT, this is the station, this is the B section. Suppose if a fault occurred in any one of in the here middle of this, and this breaker is in open position, and I am now charging the line. So this line is seeing the fault, but this breaker it is showing in the zone 2. So zone 2 pickup
This
plus
is again distance. Your line differential only explaining, right?
line distance. Same.
Okay. Right.
Zone 2 pickup and plus the breaker is in open condition. If these two conditions is there, then I am operating this here with the help of my this differential protection 87 BB of busbar differential protection. This is the end for protection. Just checking that if my breaker it is zone 2 pickup, and if my breaker is in open condition, then I am operating the differential protection, busbar protection of this busbar differential protection of this. As a safety kind of thing. This is the end fault protection. One more thing. And
What
apart
protection? End fault protection.
end fault protection means there is a fault lies between the line, but the breaker is in open condition. When I am charging the station. In that cases, when I am closing the breaker, it will on the fault I am closing, right? So it should not be done. So I am giving the signal to the busbar differential protection.
Okay.
Yes.
That means you are saying SOTF, switch on to fault, right?
Switch on to fault is the case that when the fault is there, when I am closing the breaker, when you are when you're closing the breaker on the line during the fault. So it's okay. You are saying the same. Yes. Yeah, we will call here is end fault. It is SOTF.
This word actually newly I'm learning from you. This is end.
Yes, SOTF. Like yes, SOTF in the end of same.
SOTF. That is what.
Yeah.
Same, SOTF only.
Yes. Same,
okay,
same.
Right, thank you. We have another name for this SOTF, end protection.
Switch on to fault. End fault protection. We will call this as end fault protection. Yes, okay, SOTF. Switch on to fault also same. Yes, it should be zone 2 plus should be pickup. Yeah.
Okay. Should be zone 2, right?
Yes. Zone 2 should be zone 2.
Zone 2 already at fault should be there.
Yeah, fault should be pickup. Yes, detection should be there.
Okay, right.
And also, team, one small theory here. By this, I will conclude. So, apart from this, there might be a chances of the load encroachments and power swings. That also we have to consider when we are selecting the different distance protection. Load encroachment. What is a load encroachment is? See, generally, still now we are calculating the impedance with respect to the voltage and current. We are calculating this. So this voltage and current, if I am making in a brief, so V by I, when I'm writing in a other way, so it could be like this, right? The PM square PM minus apparent power by this voltage power, if I'm converting into this. So let's see, this is the equation. Let's see, my impedance is directly proportional to the voltage and my impedance is directly proportional to my apparent power. So power also. If let's assume in the load, we cannot know, maybe on one day there is a